Our star, the Sun. It's a massive glowing sphere of hot plasma at the center of our solar system. The Sun is not just any star, it is the closest star to Earth and the most important source of energy for life on our planet. A giant ball of burning gas, primarily composed of hydrogen and helium. The Sun's core is where nuclear fusion occurs, producing the energy that we receive as sunlight. It's the heart of our solar system. Everything revolves around it, from the smallest asteroid to the largest planet. The gravitational pull of the Sun keeps the solar system in balance. The Sun provides us with light and warmth, essential for the survival of all living organisms. Without the Sun, Earth would be a frozen, lifeless rock. Life on Earth depends on it. Plants use sunlight for photosynthesis, which is the foundation of the food chain. Animals, including humans, rely on plants for oxygen and food. But the Sun won't last forever. It has been shining for about 4.6 billion years and is expected to continue for another 5 billion years. Like us, it has a life cycle. The Sun is currently in the main sequence phase, where it spends the majority of its life. Right now, the Sun is in its prime, burning hydrogen into helium in its core. We call this the main sequence. During this phase, the Sun remains relatively stable, providing a consistent source of energy. It's been shining for billions of years, influencing the development of our solar system and the evolution of life on Earth. And it will continue to shine for billions more, but eventually, its fuel will run out. When the hydrogen in the core is exhausted, the Sun will undergo significant changes. When that happens, the Sun will transform into a red giant, expanding and engulfing the inner planets, including possibly Earth. These changes will be dramatic, altering the very fabric of our solar system. They will reshape our solar system, potentially rendering it unrecognizable. The Earth itself will be affected, with dramatic shifts in climate and possibly the end of life as we know it. Understanding the Sun's future helps us appreciate the delicate balance of life and the importance of our star. It reminds us of the vastness and wonder of the cosmos and our place within this incredible universe. Deep inside the Sun, a powerful process unfolds. It's called nuclear fusion. This is the very heart of the Sun's energy production, a process that has been ongoing for billions of years. The Sun is a giant fusion reactor. It's like a furnace, but on a cosmic scale. Imagine a colossal oven where temperatures soar to millions of degrees and the pressure is beyond comprehension. The Sun's core is incredibly hot and dense. Think of the most extreme conditions imaginable. The core's temperature reaches about 15 million degrees Celsius, and the pressure is over 200 billion times that of Earth's atmosphere. Under this immense pressure, hydrogen atoms fuse. They combine to form helium. This fusion process is what powers the Sun, creating the light and heat that reach Earth. This process releases enormous amounts of energy. This energy powers the Sun. Every second, the Sun converts about 600 million tons of hydrogen into helium, releasing energy in the form of light and heat. It's what makes it shine. The Sun constantly converts hydrogen to helium. This continuous fusion process is what keeps the Sun burning brightly in the sky. It's been doing this for billions of years, but the Sun's hydrogen supply isn't infinite. Over time, the amount of hydrogen in the core decreases, and the Sun will eventually exhaust its fuel. Eventually, it will run out. When that happens, the Sun's life as we know it will come to an end. The Sun will go through dramatic changes, ultimately transforming into a white dwarf, marking the end of its life cycle. As the Sun's hydrogen dwindles, a new chapter begins. The Sun will start to die, but its death will be a slow, drawn-out process. The Sun won't just flicker out, it will go out with a bang. First, it will swell. The Sun will expand dramatically. It will transform into a red giant, a monstrous star, engulfing everything in its path. Mercury and Venus won't stand a chance. They'll be swallowed whole. The Earth's fate is uncertain. It might be consumed by the expanding Sun, or it might be pushed outward, its surface scorched and barren. The once life-giving Sun will become a harbinger of destruction. As the red giant Sun runs out of fuel, it becomes unstable. Its outer layers will start to drift away. They'll expand into space, forming a beautiful cloud of gas and dust. We call this a planetary nebula. These nebulae are some of the most stunning objects in the cosmos. They glow with vibrant colors, illuminated by the dying star at their center. The Sun's nebula will be no different. It will paint the cosmos with its final breath. This nebula will be a testament to the sun's life. It will contain the building blocks of future stars and planets. The sun's death will sow the seeds for new life in the universe. While the nebula forms, the sun's core will undergo a dramatic transformation. It will shrink, the core will collapse under its own gravity, it will become incredibly dense. This dense, hot remnant is called a white dwarf. A white dwarf is small, about the size of Earth, but it's incredibly heavy. A teaspoon of white dwarf material would weigh tons. The white dwarf is the leftover core of the sun. The white dwarf will continue to shine, not from fusion anymore, but from the leftover heat. It will cool down very slowly. Over billions of years, the white dwarf will fade. Section 6. A diamond in the sky? As the white dwarf cools, something fascinating might happen. The atoms inside will slow down. They'll arrange themselves into a crystal lattice. The entire white dwarf could crystallize. Imagine a giant diamond in space. That's what a crystallized white dwarf would be. It would be incredibly beautiful, and incredibly valuable, if we could ever get our hands on it. Scientists believe that white dwarf crystallization is possible. They're looking for evidence of it. If they find it, it would be a major discovery. It would tell us a lot about the nature of matter. Section 7. Fading away, the black dwarf. Over trillions of years, the white dwarf will continue to cool. It will eventually radiate away all of its heat. It will no longer emit any light. It will become a black dwarf. A black dwarf is a dead star. It's cold and dark. It's the final stage of a star like our sun. The black dwarf will drift through space, a silent reminder of a star that once shone brightly. The universe is full of black dwarfs. We just can't see them. They're invisible to our telescopes, but they're out there, the remnants of stars long gone. Section 8. A changing solar system, planetary impacts. The sun's transformation will have a profound impact on the solar system. As the sun loses mass, its gravitational pull will weaken. The planets will spiral outward. Their orbits will change. The inner planets, if they survive, will become distant, icy worlds. The outer planets, like Jupiter and Saturn, will move further out. They might even escape the solar system entirely. The asteroid belt will be disrupted. Asteroids and comets will be flung in all directions. Some might even collide with planets. The solar system will become a chaotic and dangerous place. Section 9. The Sun's Legacy, a Cosmic Story. The Sun, our life-giving star, has a tale that stretches back billions of years. It's a story that is both humbling and awe-inspiring, reminding us of our place in the vast cosmos. The Sun's story is a reminder of the vastness and wonder of the universe. It began as a cloud of gas and dust, slowly collapsing under its own gravity, igniting nuclear fusion in its core, and giving birth to the star we know today. It's a story of birth, life, and death. Over the course of billions of years, the sun has nurtured our solar system, providing the energy necessary for life on Earth to flourish. A story that plays out on a cosmic timescale. From its fiery birth to its eventual demise, the sun's life cycle is a testament to the natural processes that govern the universe. The sun's life cycle is a natural process. It will eventually exhaust its nuclear fuel, expand into a red giant, and shed its outer layers, leaving behind a dense core known as a white dwarf. It's happening to stars all across the universe. Each star follows a similar path, though the details may vary depending on its mass and composition. The sun's death will be a spectacular event. As it expands into a red giant, it will engulf the inner planets, including possibly Earth, before shedding its outer layers and leaving behind a beautiful planetary nebula. But it's nothing to fear. This transformation is a natural part of the life cycle of stars, and it won't happen for billions of years. It won't happen for billions of years. By then, humanity may have evolved in ways we can't even imagine, or we may have found new homes among the stars, and by then, humanity may be long gone. The Earth too will have changed, possibly becoming unrecognizable from the planet we know today. Or, we may have evolved into something entirely different. The future holds endless possibilities, and the legacy of the sun will continue to influence whatever comes next. Whatever the future holds, the sun's legacy will live on. Its influence will be felt for eons, shaping the future of our solar system and beyond. The atoms that make up our bodies were forged in the heart of a star. We are all stardust, connected to the cosmos in ways we are only beginning to understand, and to stardust we shall return. The cycle of life and death in the universe is a beautiful, ongoing process, and we are all a part of this grand cosmic story.